Hello everyone. Let me introduce you to the main part of my work, which is as follows. Power oscillation damping improvement according to SMS units connected with the main power grid. Nowadays, with the increasing demand of electrical energy and the emerging use of renewable energy resources, especially with their integration into the main power grid or the microgrid, have created new challenges for the stability of the electrical power system in terms of power quality, voltage and frequency fluctuation. Superconducting magnetic energy storage is promising alternative to improve the stability of the power supply system. On the other hand, it guarantees the injection of power into this system when it is needed. This work presents an efficient system based on an SMS unit aims to improve the stability of the power system by attenuating the fluctuation in voltage frequency due to fluctuation in the main power grid. We propose the use of SMS as a storage unit connected to DC-link capacitor, which is located between two sides of voltage source converter in order to act as universal voltage and frequency stabilizer for both sides. Simulation of the proposed system are performed by using MATLAB simulating software. The topology of the system design is this research is shown in figure 1. It's based on using SMS as an interface device connecting the utility grid side to loads and a microgrid on the other side. In this design, the SMS separates load side from the AC grid, providing improvement for specific power uses. Controlling the power flow between load and main grid and acting as backup storage device to increase the stability of load's voltage. The connecting subsystem contains two voltage source converter, DC-DC chopper and superconducting coil. The MATLAB simulating software is used to perform the simulation. The scope of the simulation is investigate the SMS system is capability of supporting the power grid. Two different distributions of the power system were simulated. System disconnected from the grid and frequency power supply fluctuation. The voltage stability across the DC link and the overall performance of the power system are compared with and without the SMS system. First, simulation of the system disconnected from the main grid. During the simulation, disconnected disturbance occur at time t equal 1 second for a period of 500 milliseconds. The voltage crossed the grid, the voltage crossed the load, and the stored energy in the SMS coil during the charging and discharging operation mode are shown in figure 3A and B with and without using the SMS. Here we have the ABC grid voltage and the ABC load voltage in case the system without the SMS unit. And here we have the ABC grid voltage and the ABC load voltage, also the stored energy on the coil in case the system with the SMS unit. 2. Simulation of the power supply frequency fluctuation. In this simulation, power supply fluctuation in frequency occur at time t equal 1 second for 500 milliseconds respectively. By comparing the simulation results between the system with and without SMS, both of the voltage across the grid and the load are shown in figure 4A and B with and without using the SMS unit. Here we have the ABC grid voltage and the ABC load voltage in case the system without the SMS unit. And here we have the ABC grid voltage and the ABC load voltage in case the system with SMS unit. It's clearly shown that the stability of the voltage across the load in the two fluctuation types that were simulated is significantly improved when the SMS system is applied on the power supply system. According the simulation results and comparing to other storage technologies, we conclude that the SMS has advantage in being able to rapidly inject both active and reactive power into the power system. In addition, with proper control strategy for power flow into and from the SMS when connected to power system, it can be used to reduce voltage and frequency fluctuation that happen after transient system. This research shows that SMS system can be a good stabilizer for power system oscillation. SMS with its ability to discharge a large amount of energy during short period of time can control the rate of this energy to stabilize the DC link voltage, which lead to increase the stability and enhance the overall performance of power system. Thanks for your attention.